Hi everybody, it's Keith with BobsCNC. Welcome to Shop Talk, and I am here as always with my best friend Bob.
And I am here with my best friend Keith.
And today, Bob, I got a question, and I know you're already prepped for this thing.
Thanks for preparing me.
Well, yeah, it's not like I have to prepare you. It takes me a long time just to come up with a question. But say I'm looking for a CNC.
Mm-hmm.
Now our KL7 series retail right around $2,000.
Yeah, the small one's 21, the big one's 25,
Okay.
2 to 3,000. Yeah.
Right. All right, but they share pretty much the same features except for the cutting area.
Yeah.
All right. Now, when I'm looking at that price range with whatever manufacturer's out there, because
Right.
I want to help people be intelligent in their shopping.
Right.
Okay. Somebody's offering a machine, same price point, but they've got this size stepper motor.
Right.
And it's the same size as our servo motor.
So like the NEMA 23s?
Yeah,
Yeah.
you got the same current.
Right.
Okay. What's the difference?
Well, the difference between a stepper motor and a servo motor is the servo motor is really a DC or a three-phase motor, and the other stepper motor is a stepping motor, so it goes from step to step. But I think, if we were to compare, and it's kind of what I'm trying to do here,
Yeah.
a stepper motor to a servo motor, just as far as the horsepower or the torque curve, right, or how fast you can go, they're all kind of related. So horsepower is really torque times speed divided by some constant, but it's conserved, right? So if you have lots of torque, you're going slow, and as soon as you increase speed, the torque has to drop off, right?
Right.
So that's true with either motor, but here we have a servo motor, which happens to be the KL7 series, so that data was easy for me. And then I went out and got some data on some stepper motors that were the same torque. So the torque on our servo drives is 435 ounce-inches.
Okay.
So I also got the same voltage and the same current stepper motors as I did the servo. So we're running these at 48 volts on everything that you see here. And the difference is this is the servo motor, and this is the stepper motor running at the 48 volts with the 4 amps per phase, right? And half step, and this is eighth step. So the half step and the eighth step are micro stepping. And if you want to learn about micro stepping, there's a lot out on the internet. We actually did a blog. You can check that out too.
Right.
But what you can see if you're looking, if this is the torque that's available at the RPM, you can see that as you go faster, you have less torque in general. But something that is interesting, if you're looking at it, is if you're taking a half-stepping stepping motor, you lose torque really fast around the 400 RPM range. I mean, there's nothing left to give there. And then if you micro-step, you even lose a little bit more torque, and believe it, at a 16th step, or some of these go up to a 32nd step, you even lose more torque.
Now, to make this a little bit more practical, because
Okay.
most guys are thinking about speed and feed.
Mm-hmm.
So, how do I translate the RPM into inches per minute?
Okay, so first of all, on a little tiny machine, let's say that you had a machine that only moved 5 inches in the X and Y and an inch in the Z, 100 inches a minute would be screaming, right? Because it doesn't have to go that far.
Right.
But if you take a 4 foot by 8 foot machine and you ran it at 100 inches a minute and you had to wait the whole 30 seconds to get from one end to the other, that would drive you crazy. So some
Right.
of this has to do with the size of the machine, but it also has to do with how fast you can cut and how much horsepower you can drive that bit to that location. So let's say for the KL7 series, we run at 1,000 inches per minute rapid. And you can see that for us, that's about the 500 RPM range. That's what it would calculate out to be. So I have lots of, I'm still in the major part of my torque curve. You could ask, why can't I run at 1,600 inches per minute? I would still be better than most stepper motors given that same size with the same current. The answer is really the microcontroller won't pulse that fast, right, with the resolution. So we want to keep it in the safe zone, and we thought 1,000 inches a minute was fast enough.
That's moving pretty good.
We actually tested our machine at 1,500 inches a minute, and
Right.
it will work. but your processor might not be able to keep up with a lot of the little moves. Okay? So if I have a stepper motor, that's why stepper motor systems are a lot slower than servo systems, because you have to design within the torque limit that you have. So you're going to be down here somewhere in the 300 to 400 RPM range, right, which is going to calculate to a lower feed rate. And the faster your feed rate is while you're cutting, the less power that you have. If you cross that boundary where you don't have enough horsepower to drive that bit to the location, you will skip steps, right? So your stepper motor won't actually get to where it's going. And you've seen this, it'll be like a double line in your carve. Right? Because some axis is shifted, or if you actually shift both of them, you know, it'll be kind of at an angle. So the stepper motor system is we've talked about this before, it's the open loop. It doesn't know that, so it's just going to keep on cutting. If something would happen with the servo drive, it has encoders. It would send a signal back to the controller saying, hey, I'm somehow not where I'm supposed to be. I'm stopping this so you can investigate it without ruining your work. So that's really the difference. So I'm comparing a 435 ounce-inch motor to a servo motor. The truth of the matter is if you go out and look for a CNC, that's one thing that you're going to want to see. Because if you have a 280 ounce-inch, you're going to start here and work your way down. Or if you're a Evolution 3 or an Evolution 4, we have 75 ounce-inches of torque. And again, the reason we only go 300 inches a minute is because we want to be in that torque band.
Right.
So we have plenty of power to drive our system. So you were talking earlier, you had a friend that beefed up his engine and tore out his transmission.
Yep.
It
too
is,
much power.
Yeah, it is definitely a system that you can actually add too much power and tear up things. So the system needs to be designed within its capabilities. So when you're out there looking for a CNC, we really believe that our KL7 series is the best value on the market, but you'll want to research that yourself. And that's all we have for today, I believe.
Yeah, so if you guys got any questions, give us a holler at the help desk at BobsCNC.com, or you can get a hold of us, of course, at Shop Talk at BobsCNC.com too. Until next time, we'll see ya.